All right, we're going to take a look at two forms of lines that we're going to use on a regular basis. So there are different ways that we can set up our equation to represent a line. The first one we're going to take a look at is the most commonly used, and I would make an argument it's the most important one, because you can always get away with using this form, whereas the second equation we're going to look at is on occasion more convenient, but then you have to do some extra work, and generally you want to put your line into this form that we're starting with in the first place. So to me, my preference is always just to work with this first form, but it's up to you because you can do the problems either way. So this first form is what we call slope-intercept form, right? It's y equals, let me change this to m. Sometimes we'll use a, but it's pretty, you may have seen this before as y equals mx plus b. So the form looks like y equals mx plus b, and this is what's known as slope-intercept form. It's really convenient because we get the slope and the y-intercept right there in the problem. So you know a whole bunch of really important information about the problem just by looking at it. You don't even have to do any calculations or anything, and you know an awful lot. So in this y equals mx plus b form, if you can get, however the equation of the line is that you're dealing with, if you can manipulate it using your algebra and put it in this form, you automatically know the slope, which means you don't have to go through and calculate using the slope formula, and you already know the y-intercept. So you can graph it without any additional work. You don't have to plot points. You know the slope, which is the rate of change, which is really important. It's really convenient. So a couple of steps to put your line in the y equals mx plus b form generally pays off in all the other work you don't end up having to do later. So we can see here, if I take my line and I change the m value, what it's doing, it's changing the slope. It's changing the steepness of this line, right? In fact, let's go ahead and go like that. So we're changing the steepness, and the b is the y-intercept. So whatever that number is on the end of the equation, that b form right here, whatever that number is, that's your y-intercept. So it makes it very easy to go in and graph it. And notice if I change that value, it's just changing the intercept. Okay, so this makes it really easy. What if I had something like y equals 2x plus 3? Well, just by looking at it, I can say, well, my slope is 2, because that's a 2 right there. And here, this is a 3, so my intercept is 3. So what this line should do, it should go through the point 0, 3, because that's my intercept. So if you were to graph this, here's how we would go through and graph this. You would say, okay, my intercept is 0, 3, getting the 3 value from right here. And my slope is 2. Okay, so starting from this point, if I go up 2 and over 1, so up 2 over 1 puts me at 1, 5. And then sure enough, that's my other point. Now you can draw the line through those, and you get the equation of your line. So this is a line with slope 2 passing through the point 0, 3, where that's our intercept. So really convenient to graph these. You don't have to plot points. You don't have to make a table. You don't have to go through all that work. You can just go ahead and graph the thing. And it works both ways. If you know your slope and you know your intercept, it's really easy to just construct this line. If you have the line, it's really easy to break it down and make the graph. So either way, it's very convenient to go through and do that. All right. Then we have the other form of a line that we're going to deal with regularly, which is what's called the point slope form. So the point slope form involves a point on the line and the slope. So the problems where you'd really want to use the point slope forms are the problems where in some way you've learned a point on the line and you know what the slope is. If you know those, you can just plug it into the point slope form. However, the point slope form has some drawbacks, so we generally don't like to leave our answers in point slope form. In fact, you can assume, unless told otherwise, your answers on tests and quizzes and assignments should end up in that form we just looked at, the slope-intercept form. So although this formula can make it easier to start certain problems, then you have a little bit of work on the end, not too much work, couple steps, but to put it in that slope-intercept form. So this form right here is based on having a point that you know the information about and the slope. So the m is still the slope, we see that right here, and your x1 and y1 are the values from a point that you know, okay? So we can play around here with this and say, well, we can see how that m value is changing the slope. And we can see how this is changing the location of the thing. Here the slope's staying the same. So that's, if you look at the following videos, I'm going to walk you through some of these problems so you can follow along and see how to do those. So let's just take a look at an example. What if I had the problem y minus 2 equals 3 times x minus 4? All right, so let's move this over. What do we have here? Well, according to our equation, right, this should be our y value for our point, and this should be the x value for the point. So you can kind of see what variable they're with. This value is with this y, this value is with this x. So that's the x and y from the point that we know. So in this case, we're getting it from the equation, so that means this should go through the point 4, 2. And sure enough, we can see that the point 4, 2 lies on the line, and our slope should be 3. So let's see. Oh, and we go up. So for here, and we go up 1, 2, 3, and we go over 1, that puts us on the line again. And if we again go up 1, 2, 3, and over 1, that puts us on the line again. Okay, so that's how you would go through and use this to graph this form of the line. Okay.